Hey, what's up? It's Jake from Nimbus DevOps, and we are going to start in on some microservices. So, we've been messing around with our pods and stuff like that, and we've built some pods, right? We built a backend pod and a front end pod, and then we use replica sets to scale them automatically, and then we use deployments and took that one layer further. And then we started talking about services, and we did a big long one on NodePort, and we set that up, and we had access to it, which is cool. But that's like one tier, right? So we want to look at creating a couple different tiers. So we're going to make a front end and a back end tier. Docker has a let me pull it up here. So there is a Docker examples, not the samples. Is it samples? Yeah, there's an example voting app in here that's used in a couple different places. If you ever buy a course on Udemy or the Mannambeth stuff from KodeKloud, they all kind of use the same like 5 or 6 kind of app concepts. And Docker samples repo has some really good ones. And one really good one is the example voting app. And it's a distributed app. And actually, I'm going to click in here so you can see there's an image of it. It's set up like this. So you've got your voting app, and then there's a Redis database, an in-memory database that takes the vote and saves it. And then there's a worker written in the back end that does a calculation and then stores it into a database. And then you have a result app that renders that result that's stored in the database. So this is kind of what we're going to build. And we'll start off doing the pod version of it, and then we'll do the deployment version of it, and so you can see what the services are doing. I could just build it with the services, but it's kind of like really fast, so I'll do it the long way. Okay, so I have this voting app directory, and in here I've got all my pods. So let me go into my pod directory. Pods. There we go. All right, so here we are, and let's just make sure I don't have anything running. I have one cluster IP service. All right, cool. So all I'm going to do is I'm just going to say kubectl apply -f dot, and that's just going to create everything with every file I have in this current directory, the dot. So now I have everything running. As you can see here, I have a Minikube dashboard running already. So should be able to just pull this up. There it is. I've got one failure, and I've got the rest of this is working. And this might be due to the fact that I don't have a service, so it can't connect to anything. But let's just go ahead and check. So in this pod, we can see our events and see that it got the container, and then it couldn't start, basically. So I'm going to go ahead and make the services 2 and see if that fixes it. So the reason for that, if I go to the GitHub repo, so this is the pod that's not working, and because the reason it's not working, my guess is because it needs to communicate with this Postgres database, and Redis needs to be able to communicate with it. So it's not getting any input, and it doesn't have an output location. It also probably doesn't have the credentials to connect, or it does. Maybe it does. The Postgres pod. Yeah, I put them in here. So let's go make some services. So if I look at here, I have a Postgres service, a Redis service, the result service, and then the voting app service. So I touched briefly on services, but so let's talk about this. So in the voting app and in the result app, they're both NodePort services. So the reason for that is because these are front-end facing applications. So you as the user are going to connect to the voting app and connect to the result app pages in the browser. So we need to expose this, so that's why we used a node port. Now the voting app needs to communicate with Redis, so that's an internal thing. And Redis needs to communicate with the worker, that's an internal thing. And so on and so forth, it goes down. And that's why if you look at the Redis service, you'll notice the type is not set to node port. And there's no type actually, and so by default it's actually going to create a cluster IP service. And this is just an internal service for the cluster itself, so the pods can communicate with each other. So we have a Redis service, we have a Postgres service, and we're going to go ahead and create those now. So we'll just do a kubectl apply -f and then Redis service. And then we'll do the same thing for Postgres. And that gives us our Postgres service, our Redis service, and all that's left is the result app service and the voting app service. So we can actually go ahead and make those two. So here's our result app service. And then we need our voting app service. And there we go. So now if I do a kubectl get deployments, we should be able to see, oh, I don't have any deployments. Let's do kubectl get pods. Okay, so everything is running. Notice that our worker pod is no longer in an error state. And then let's get our services and make sure those all look good. And we can see here the database, the internal Kubernetes, and the Redis services are all type cluster IP. And then our result and voting services are all node port, which is perfect. Let's take a look at the dashboard. Okay, so you can see here it was able to connect and everything looks good. So I'm going to go back to my workloads page and see that I have 5 pods. Perfect. 1 pod for each part of this app. And there's 5 parts of the app. So everything looks like it's represented. So the only thing we have to do left to do now is to grab the result service and the voting service URL. So because I'm using a Docker driver, it's going to be taking this random port on localhost and mapping that to, like in this one, the voting service, for example, to port 30,004 on the node for my Kubernetes cluster, which I already went over that. So let's go ahead and take a look at this. So this is the voting app, cats versus dogs. And you can see that the container ID, we have our little pod right here. And you can vote. Cats or dogs, pick one, I don't care. So then let's check the other one. So this is the service for the result page, the result app. And the result app shows the result from the votes. Now I'm the only one voting. There's only one vote, so 100% is cats. And you can see if I refresh it, it actually remembers what I voted for, because not only is it stored in the cache, but it's also stored into my database, my Redis database, in-memory database. So there you go. I have a front end, 2 front-end apps actually, and we have an in-memory Redis database storing our votes. We have a Postgres database storing the results of the votes, and the results are being calculated by a back-end worker written in .NET. This one, by the way, is written in NodeJS, and this one is written in Python. So you have 3 completely different programming languages using the same ecosystem and are working together flawlessly. So it's kind of cool. You can mix and match things like that, and you don't have any compatibility issues. So that is how you do this with pods and services. So there's a better way to do this, because we might want to scale parts of this. So what we're going to do is we're just going to go ahead and stop everything in here. So I'm just going to say kubectl delete everything that's in here. I got an error for the files, for the deployment files that we haven't used yet. And if I go into the, so now all I did here is make services, right? All these services were deleted. So if you go back to our dashboard, our pods are still up, right? But my services, all that's left is the default cluster IP service. So we want to delete these pods. So I'm just going to change directories into my pods directory and just delete everything in there. And then we can watch this start to offload, terminate. And then these will be gone because those IPs are being released and the ports are being released. And as soon as these are terminated, we can go ahead and start with the build of our deployment. So while it's doing that, I'm actually going to create a service directory, or services, I guess, plural. And I'm just going to grab, well, I guess I should, yeah, I'll just leave it the way that it is. We're going to leave the services and the deployments in the same directory. So just like I deleted everything with one command, I'm going to get out of my pods directory, and now I'm in my voting app directory. And you can see in here I have some deployment files, and I have some service files. Now, what we need to do also, we haven't really gotten into this, we need to start talking about manifest files and talking about these as manifest files, because that's what they are. So all we need to do is a kubectl apply, and I'm doing apply instead of create so that I can do this declaratively. -f dot, and this is going to create my deployments and my services. So I've got 5 pending deployments. They're going to make 5 pods, 5 replica sets, and that's done. I go to my services, and I've got my services all running for my database, Redis, my voting service, my results service. Everything looks great. So if we go back to workloads, and we can see what exactly it is that I'm running here, everything's up, it's super fast. And if I go here and I grab the new addresses for our URLs, we got our voting app is going to be here, and we got our results app, which is going to be here. So we can see it's 50-50, it's tied. Vote for cats, now it's 100. Vote for dogs, now it's 100 over here. So this is still working, which is great. So we just changed it up with deployment files instead of the pod definition files. And now what we can do is, let's say that we want to scale up our voting and result replicas to 3 each. I want 3 voting app pods, and I want 3 result app pods, because we have a lot of people hit the front end, but maybe the database doesn't need any more than 1. So I can change that, I could update it. Now, and ideally, and we'll get to this eventually, you would be updating these files in Git version controlled and have a CI/CD pipeline that updates this, and then we'll eventually apply those changes. And once they're applied, we can see I still have 5 deployments, but I now have 9 running pods. And you can see here, pods, 3 of 3, 3 of 3, 1 of 1. And I could do the same thing here with a get all for like an overall dashboard. And you could see all of that. Or we could do just like a get service. Or there's actually a comma feature where you can say, I have an alias, but kubectl get, and then say deployments / services. Did I not make an alias? Sometimes I don't make aliases. Get service, get svc, get svc / pod. Huh. I've done this before. I guess it doesn't. Oh, there we go. It doesn't like the space. That was my bad. I didn't remember that. So if you do svc / like deployment, for example, it'll show both, but in between these two, you cannot put any spaces. I forgot about that. So there we go. You can see the same thing. 3 of 3, 1 of 1, etc., etc. And you can see what type of services these are running and how they communicate with each other. So this is a fully functional application now, and this is all running in Minikube on my gaming PC. So if you built this in a public cloud environment and you wanted to change the result app service and the voting app service, with a type of load balancer instead of node port, the application would basically work exactly the same, except these IP addresses that I've been getting for the web page that you see here, these IPs would basically be a public URL endpoint in AWS, for example, of a like an ALB, and you could put that in Route 53 and attach a CNAME to it, or have a domain forwarding traffic to these IP addresses. And it would just be hitting your load balancer. Load balancer would be forwarding that traffic to the appropriate node, and then the node would just use the internal cluster IP stuff from there. So anyways, that is essentially a quick down and dirty on microservices. So what you're seeing now is each pod or each piece of the application is being broken into individual components and defined in a definition file as a single pod. Each pod is going to be communicating externally or internally with the representation of a service, which allows one single point of reference for your application to ask for, in this case, a voting app pod. And instead of it having to know where all the voting app pods are, it just forwards it to a service, and the service will act as an internal load balancer for that. So yeah, that's pretty much it. From this point, I'm going to go ahead and tear all this down. So you can do that with me if you're following along. Just stop your, if you're on Windows using a Docker driver, go ahead and stop the service URL generation. I'm going to turn my Kubernetes dashboard off. And then, real easy, I'm just going to say kubectl delete -f dot, and it's going to delete my services and delete my deployments. And I can do a kubectl get svc for service and see all the services are gone, and do the same thing for my deployments if I can learn how to spell the word. Yeah, and they're all gone. Let's just do a kubectl get all, and we can see that there's still some pods being torn down. We're almost there. 2 of them are gone, and now they're gone. We're all cleaned up. So at this point, this is going to conclude this part with the Minikube stuff. So I'm actually going to stop Minikube, power this off, and then we're going to delete our Minikube cluster, because the next task we'll be doing is taking all of this knowledge and creating a multi-node cluster. So that's something that we have not delved into yet, and it's a little bit more complicated. We haven't gone over all the specifics of everything, and there's probably people like, there's so much more to it than that. And if you know that, that's great, but not everybody knows that. So we're just going to go nice and slow, and I'm going to make sure I cover everything, because I'm going to go take the CKA and CKAD exams. And so I'm just going through every single piece of documentation really slow and making sure I know this. So I actually go to either my gaming PC at night every day, or go to a brewery at night or something, and I start from nothing, blank files and everything, and I build out a Kubernetes cluster with some kind of scenario, and see how far I can get. So that's, if you're studying for exam, I think this kind of stuff is exactly what you need. So for now, that's it, and yeah, the next one I'll see you in will be multi-node stuff. So look forward to it, and I'll talk to you later.